Peace out, my damn. An 8. Corey, you're number 30.
Is that what the fight was about?
Are you guys gonna come to our district game on Friday? I don't really care if you come tomorrow. But...
It's in Omaha. You went tomorrow.
No, go to the one on Friday.
Why?
Because we'll win the win tomorrow.
I'm going to both. You want us to watch? You want us to watch?
Yeah.
Okay, everybody get noise off.
Yeah.
That's how you thought?
You don't need to add to it.
Dang it. I was doing so good.
No. I'll give you something less to everybody does it better. That okay, we deal with solubility equilibrium and ionic solid, specifically ionic solids that are partially soluble. We're always going to write it when we have an equilibrium involving them, a saturated solution type of thing. We're going to write the equilibrium starting with the solid going to the dissolved ions always, regardless of how they talk about it. This is a specific type of equilibrium, and we will call this equilibrium constant a KSP. For example, in this one, how do we go about writing equilibrium constants in general? In general, what do we have? Products on top, reactants on the bottom. Okay. What doesn't show up in equilibrium? So that means all we have left are these two, right?
Taping.
Now, we can work with this in a number of different ways. One is, if we know KSP, we can solve for these concentrations. This is the amount left at equilibrium. So this is what has dissolved. Right? So if we have the KSP, we can solve for each of these. How would these, if I start with AgCl, how will these two concentrations, I put the square brackets mean remember, how will these two concentrations compare? Well, all I've done was to start with AgCl, throw it in water until I get as much dissolved as I can. How will these two concentrations compare? Equal, because we get 1 Ag for every Cl, right? So if I know this value is something, I don't know what that value is off the top of my head, but I'm going to make up a number here right now. So we're going to say that this is 4 times 10 to the minus 9.
Wait, how about?
Let's say it's 4 times 10 to the minus 10.
Hey.
This by any chance isn't the one they give you, is it?
Wait, how about 3.5 times 10 to the minus 8?
Okay. Is that this one or something else?
That's this one.
Okay? So, therefore, I don't know what either of these two is, but I know they're going to be equal to each other. Okay? If all I've done is start with AgCl and put it in solution, I'm going to get a little bit dissolved. Not a lot, because this is a pretty small number. So the product of these two would have to be this, right? So therefore, I'm going to let X equal the silver ion concentration, which will be the same as the chloride ion concentration. Therefore, this is X times X, right? Otherwise known as X squared.
Oh.
Or around X r squared. How do we solve that now?
Oh, I got it.
And get the calculator, hit the square root button. What does it tell me?
Chia.
What does it tell me?
Oh, you want me to do my calculator on?
Like, have that number, hit the square root. Of that number, what do I get?
How do you do 3.5 times 10 to the negative 8?
3.5 e to the negative.
Didn't you just say it?
3.5 e enter exponent negative 8. Square root first.
2 E's or just 1?
The e key. Somebody point out that key.
Okay, I got it. 1.870828693 e to the negative
How
4.
many significant digits of that can we keep?
1.87 times e to the negative fourth. What?
Okay?
I just said it. Claire, I was like,
Why do we know AG equals CL from our balanced equation? If all we've done is start with AgCl and put some in water.
Yeah.
For every one of those dissolves, I get one of each of those, right?
We're at 5 minutes.
So they should be equal
We're at
concentration.
5 minutes.
well, that's
Now,
5
if
minutes
they
too
come from
long.
different sources, that won't be true. If I have AG from one thing and CL from something else, that wouldn't be
What class do you
true.
do that for?
AG was not solid, AgCl
Oh,
was
calm.
not solid.
That's
And we
fun.
wouldn't
Are you
have
gonna put me on the video?
ASP for it.
So you wouldn't have that.
This is specifically an equilibrium for ionic compounds that are partially soluble.
So this would be from solid onto AG.
Right.
I can't do that no more.
Pre-kick. Man's best friend.
It's not pretty calculated.
Okay?
This goes like right there.
Now, what if it's,
Man's best friend.
so this is pretty straightforward. If you're given that and you start with that, you're gonna get those things. What if it isn't quite so neat mathematically?
Are you gonna do
We
this?
have a different
I have
one here.
one
Let's say
or
we
2
have-
problems to do.
Are you gonna do this?
And then
Let's say we have
You get them.
lead iodide.
What are we doing with history today?
What are we going to get when the lead iodide dissolves?
I actually kind of like being here because then I can actually say what.
We get PDI2 plus 2 and
I.
negative 1, 2 I. So when we write the KSP expression here, well, actually,
No, it's not.
yeah, this is a solubility one specifically.
Dude, Johnny, it's been recording for like 7 minutes now.
Oh, I thought that damn thing was faking
No,
that
always gotta get
Oh.
this thing right first. One step at a time. In Sydney, well, when we have
shit. Shit, man, I'll do it. I don't give a fuck.
B plus 2 in square brackets, that means the whole concentration of that.
And then, bracket 2I. No, okay, it'd be the I minus,
I minus,
then there's a 2 at the top, isn't there?
and there's an exponent 2. Okay, it makes it different, doesn't it? The KSP for this has a KSP table in it. KSP for this one,
Where's the comma?
So it'd be X to the third.
What you doing?
no, there's some KSP.
Hold on.
Lead iodide, 8.7 times 10 to the minus 9.
So would you just agree with that?
If we started with lead iodide and dissolved it, if we let X equal the concentration of the lead ion, what will the iodide ion concentration be? How will these two concentrations compare?
One is twice the other.
One is twice the other, which one is twice the other? So X
So we
is
can
the
see.
lead ion concentration, I minus will be 2X.
Tristan, zoom it in.
Right, now we put those in there. Right? Okay, I know a lot of people, well, you're using that twice. Yes, we are, but we have to. This concentration will be twice of this because we're getting 2 of those for every one of those. To have this work, that had to be a square there. Okay, so now what do we have? 8.7 times 10 to the minus 9 equals what? 4x cubed. So 8.7 times 10 to the minus 9 divided by 4, different than that. 4x cubed. So we divide, take the cube root, we would have it. Can you take the cube root with your calculator?
Yes.
Is that
Yes.
I don't get it. I'm not running from this thing.
Okay?
Hold on.
This is solubility.
I don't remember.
If you are given, you can also approach this where you are given the KSP and one of these two